Okay, good morning and welcome to our panel on infrastructure for cloud computing research. My name is Jack Brassel from Princeton University. I'm delighted to be here today and we'll shortly welcome a panel of distinguished and informed speakers on cloud research infrastructure. I'm going to kick off and we'll proceed as follows. So I'll say a few remarks based on some of my recent learnings about cloud computing research and the infrastructure needed to support cloud computing research. And then I will hand it off to the panel to say a few remarks on their own, one by one, at which time, when they're coming up, I'll introduce each of them. So to begin, why don't we start reflecting on what we know about the existing cloud research infrastructure, particularly the shared community testbed that NSF has supported. So I've been an observer of this, having served at NSF alongside Mimi, our earlier speaker, for a number of years from 2015 to 2018. During that time, I got to oversee some of the cloud research infrastructure projects. So I'm familiar with, I think, a snapshot of where each of those projects is today. So critical projects include the NSF Future Cloud Program projects, Chameleon and Cloud Lab. Both are represented here today. Each of these projects has been up and running for over 6 years. So we have considerable experience on what the infrastructure has been, how effectively it has worked, what kind of experiments the community has used the infrastructure to support. So NSF has also reviewed these programs regularly, including holding many numbers of workshops to sort of assess the community's satisfaction with each of these cloud research infrastructures and help the developers plan about for future enhancements to each of those infrastructures. So fortunately, we recently held yet another one of these in November at Princeton that I was involved with. And what I'd like to do, just to kick off our discussion this morning, is talk about some of the learnings, both from that workshop and from a survey that we conducted leading up to that workshop to help understand the broader community beyond the folks who would just be in the room for that particular event. Musharraf Chowdhury from the University of Michigan and I put together a community survey. We reached out to the audience of all of the known experimenters that have in the past used Cloud Lab and Chameleon and other infrastructures. So we reached out to several thousand experimenters. We heard back from over 200, which we were delighted that we got a broader sense from the community of where they were, what their interests are going forward, and their satisfaction with the infrastructures as they exist today, and opportunities for going forward. So a few of the learnings, I'm going to give you kind of a top 10 list of some of my takeaways from that survey and what the community had to say. So lesson one, and I was delighted that this was, I think, one of the most important learnings to call out, is that overall, the research community is extraordinarily highly satisfied with the existing cloud research infrastructures. Now, having been at NSF for a while, I can assure you this is a tough crowd to please. So the fact that they were reporting such satisfaction with these infrastructures, what they provided to the community, and how effectively they were operating, and the service they were provided by the developers and the operators is really an outstanding affirmation of many of the programs that NSF has sponsored. That was the first learning. Another thing is that learning is that there's quite a community of users that kind of move from one infrastructure to the next. So there's considerable evidence that users of earlier research infrastructure systems, and I'm going back in time now to point to some of the systems that Mimi mentioned earlier that CRI had supported in the past, such as Planet Lab and Emulab. Users of those systems, experimenters, have moved forward over time and have started adopting newer infrastructures So that community has kind of remained intact and grown over time. So that's fantastic that kind of once the community, once you're a member of this community, you see the benefits and you're more likely to stick with these infrastructures to provide service. So we learned a lot about experiments themselves and what researchers are doing on each of the research infrastructures. There are many learnings here. I'll just point out one. And so the lesson was that even the biggest experiments remain fairly small. So this is not a particularly new result. I think Rob wrote a paper 8 or 9 years ago, at least, where he reported something quite similar, that experiments stayed small. But research infrastructures have changed, they've grown, there's more facilities available, but it's unclear that experiment size, the number of machines or containers or whatever the unit is that's of interest to you, that's being used by each experimenter tends not to be growing. There's many other sort of corollary results, like experiments are not particularly long-lasting. They're all generally fairly short duration. And a number of other learnings we have about how researchers are engaging with these facilities over time. Another lesson is that users of these systems want both kinds of access. They want on-demand access. They have an idea. They want to dive in, get some resources, and go to work right away. And they also have demands that are much more scheduled, with papers approaching or big experiment needs that might be rare. And they'd really like to be able to go in and reserve or schedule access to some dedicated facilities to execute those particular experiments. So another learning, and this is where things start to get tricky for planning future infrastructures, is that these infrastructures are used for experimentation across a very wide range of topics, research topics that we find in the SCIES research community. So it's a little bit hard to pin down exactly what kind of system work is going to be done. There's some networking work, storage work, database work, you name it. It appears to be happening on these infrastructures. That's fantastic news, but it also doesn't tell us too much about how to weight investments in the future. Okay. Another question the survey asked of the community was, what kind of specialty hardware components do your experiments rely on? We'd like to get some insight into what's important now and what kind of specialty hardware we should be building in the future and enhancing the existing infrastructures with. And once again, the community is difficult in that they're very broad in their interests in the kind of technologies that they need. Here's a snapshot of their interest in, say, FPGAs and GPUs. So we have a sense of what they're using today. It's a little bit more difficult to talk about what resources they'll be needing in the future. But I did want to point out that it appears that there's a pretty good match with the demand for FPGAs and the scale and the type of test bed that the open cloud test bed appears to be going after. So if they can address that subset of the community even more effectively, this could be a fabulous match. I'd be a little more concerned if 100% of experimenters said they wanted FPGAs, that maybe we couldn't accommodate that kind of demand with the open cloud test bed, but there appears to be a good match. The vast majority of experimenters have some commercial cloud experience. This is increasingly crucial as we're trying to understand the relationship between cloud research infrastructures and commercial cloud and how experimenters view both of these tools in their toolkit. They tend to think of them as separate things today. And perhaps as we hear more from about hybrid infrastructures, which Giovanni was talking about this morning, and the tighter marriages between campus research computing and some of the commercial cloud systems, we'll get different reports about experience and behavior using commercial cloud systems. Another lesson is the major barrier today for experimenters in commercial clouds, as we well know, is how to pay and uncertainty about the costs of using commercial clouds. They want what's there. Nobody seems to understand how they're going to pay for it. Maybe it doesn't fit with their grants or their other funding mechanisms. And absolutely nobody seems to understand what next month's bill will look like. And that includes me. When I play around with these clouds, I see order of magnitude, even 2 orders of magnitude difference from month to month in how much I get charged for whatever dabbling I do. Now that's great for me because I'm way down in the noise and I'm just dabbling. I'm not a 20K a month user, but caution for the 20K a month users. One thing that the commercial clouds don't do that the existing research infrastructure do a fabulous job with is meeting experimenter needs for isolation, predictability, and repeatability of experiments. So that's a huge win. We've talked a lot about isolation, separating experiments, and the importance of that, including on the open cloud testbed. But we should know what the sweet spot is for using these infrastructures going forward. And last but not least, kind of peering a bit into the future, what kind of activities, what kind of research topics are you most likely to be involved in using commercial clouds in the future? And I was a bit surprised by this particular response. There's a lot of interest in using machine learning and analytics in the future. That much I got. Surprisingly, the research community was not really looking for compute, basic compute in compute clouds. I'm not entirely sure why, but if you ask them about scaling and Lambda services, that was not what they currently seem to be looking to commercial clouds to satisfy. So some of the tools, some of the software, yes, compute perhaps less so. Okay, so just to summarize that before we turn over to our panelists, commercial clouds are a tool in our toolkit as experimenters. We can't really compete with their offerings when we think about what we should be doing with cloud research infrastructure. We don't want to be competing with them, and I think we'll hear more about that from our panelists today. So we really need to focus on what the academic vehicles we've created are good at, including repeatable experiments, including low costs, including serving underserved institutions, all of which they're a perfect match for, and I expect they'll continue to be. So I wanted to kick off with some thinking about where we are today, where things might go, but let's hear from more of the experts. So we're going to start with Bar von Ossen from Rutgers University. So Bar, why don't you come up and I'll introduce you. So Bar von Ossen is the Associate Vice President of Advanced Research Computing at Rutgers University. He is responsible for providing strategic scholarship and advancing Rutgers research and scholarly achievements through next-generation computing, networking, and data science infrastructure. Thanks for joining us, Bar.
All right, thanks very much, Jack. So as Jack was saying, Associate Vice President for the Office of Advanced Research Computing at Rutgers University. Before that, I was at Clemson University for 17 years, and I was directly involved with the Cloud Lab project when I was at Clemson. So I've known Rob for a while, and Casey Wang at Clemson and I are always having conversations, and so we've been brought into discussions around the Fabric project as well. So, all of this is converging. But so today I'm going to talk about the Eastern Regional Network, which I feel is very synergistic with the Open Cloud project. So to kind of step back a little bit, where did it come from? There's been a lot of discussions about building out these research platforms across the U.S., and Europe and Asia. So, how do we start working together, being able to collaborate better? And so Larry Smarr created the Pacific Research Platform in California, And that was a great project that he's been working on, and a lot of us got very excited about that, and that led to a discussion around what would happen if we expanded that to a more national sort of a level, and there were several meetings around building out a national research platform. So anyway, there were several of us from the Northeast that attended those meetings, and we felt that there were pieces that were missing from that discussion that were unique to the Northeast. So just to give you some ideas, with the Pacific Research Platform, they were working with the entire California university system and partnered with CNIC, which is their regional network provider, and they built out the infrastructure across the state of California. In the Northeast, because of the smaller states, we all have to cross borders, which means we have to work with different regional network providers. And so when we started looking at the Northeast, instead of having one to work with, we had 9 to 10 to work with, right? And that gets very complex where you have to look at the cross connects between all of these regional providers and how to get them talking together. The other thing that's interesting is if you look at all the different types of schools within the Northeast. So right now, we went out and sort of did a quick scan on a site that listed the different colleges. So there are approximately 2,000 colleges and universities of all shapes and sizes in the Northeast. So what we're finding is that the smaller schools, the underrepresented schools, are just as interested in getting access to this. Many of us are land-grant institutions who are very interested in working with that community. So how do we partner with the regional network providers and all these schools and come up with a solution? This is John Goodhue actually did this calculation. The Northeast contains 8 different state university systems in an area comparable to California. So, so all of these together sort of add a complexity, makes it much more complex to try and build out solutions across the entire region, and so it becomes extremely challenging. So after the National Research Platform meeting, we convened at Rutgers to try and decide on how we would address this, and that's where the Eastern Regional Network came into being. And so the first thing we wanted to do was create a vision and a mission, and we tried to keep it as simple as possible. So the vision is really just to simplify the collaborations and to help advance the frontiers of research, pedagogy, and innovation, right? So it's all about the research, it's all about the education, keep it simple. And so the question is, how do we do this? And so I think this is where it's synergistic with Open Cloud. So through partnerships, educational institutions, research facilities, regional network providers, Internet2, commercial cloud providers, other groups within the area, how do we work together? And so we're trying to come up with a layered and transparent access to shared data, computing, and other core facilities. So the way we think of it is, as we build out these solutions, it's really cloud infrastructure, campus-level cloud infrastructure. So bare metal, virtualization, containerization, close to the instruments, close to the support teams, and plays an incredibly significant role in advancing the research. So above that falls all the national resources like the Exceeds, the Cloud Labs, the Chameleon, all of these different projects, and how do we interact with that? And then you've got the cloud services, and then I always like to think of Open Science Grid as sort of coming from underneath and sort of grabbing unused cycles when people aren't paying attention. So we've got all these different layers that we have to sort of work our way through. And so the ERN is really interested in doing that, trying to make it as transparent as possible. So it's a major task to be able to do that. And the key to all of this is because of the, we're all building out our systems on our campuses. They're all, heterogeneous. And so how do we take advantage of that? And so the last one says, a broad range of collaborative, multi-institutional resources that are not available on any one campus alone. We have to do this together. So we built out a proof of concept just to test out ideas as an experiment. We've got about 10 sites now, but we've been experimenting with federation, bare metal, containerization, commercial cloud. So we partnered very closely with Google. They actually went to the SCED-MD, so the scheduling group, and helped them write code that will allow us to burst directly into the cloud. So now we can make the cloud look like it's just a piece of this environment. A user gets on, they submit a job, and it can go to cloud, it can go to any of these sites. It just all looks like a single system. We're experimenting with Ceph, Kubernetes, and FPGAs. So Intel and Dell donated a few boxes of FPGAs that we put in the system. And so we've been doing some training. There was a class out of Penn State that took advantage of that, and they were experimenting on those FPGAs. And now we're looking at ways to containerize solutions or applications that will use FPGAs to make it easier for others to adopt. So we've been working on that. So it's a work in progress, and we're, like I said, it's just experiment. Partnerships, so the academic institutions and the organizations. So we've got 9 states, 10 research and education networks, and 24 college and universities that are working with us. We have regular calls where we discuss different projects and how we move forward, and so these are all the schools that have been participating regularly on them. So that's what I have. Thank you.
Thank you, Bart. Okay, next up is Paul Ruth. Paul is a senior research scientist at Ritchie, UNC Chapel Hill. He is a researcher in both networking research and infrastructure, and his interests include building and using dynamic cloud computing and networking test beds for software-defined exchanges targeting data-driven scientific workflows. Paul is also co-PI of the Chameleon Cloud Research Infrastructure. Thank you, Paul.
So the slides look a little funny. There's supposed to be like green stripes and a bunch of extra logos here. I'm not sure what happened, but this is supposed to be the standard Chameleon slide set, but with new words on it. But I'm not. Anyway, we'll move on. So, like Jack said, I'm Paul Ruth. I'm putting my Chameleon hat on today because I think either Kate or I were going to be on this panel. Yesterday you saw me on the Fabric hat, but the truth is that I kind of sit right between the two, and that on Chameleon I mostly do the networking pieces of Chameleon, and on Fabric I do all the things Fabric. So everything I say here probably is biased towards the networking part of all of this cloud stuff. Since we had a couple extra minutes, I might point out that there's been a lot of talk about Cloud Lab today, and because Rob's big here, and Massachusetts Green High Performance Computing Center is going to have a Cloud Lab site. So Chameleon, if you're not familiar, is the other NSF Future Cloud. Roughly has the same capabilities. The differences are that Chameleon is based on OpenStack, uses Ironic, which was talked about yesterday as well. And we have 2 sites, one in Chicago, one in Texas Advanced Computing Center. And we at Ritchie have been working a lot on Chameleon, so we can do a lot of the network stitching and things like that were brought in from Genie, which Cloud Lab can do as well from Rob's side. So that's kind of what I'm talking about, or what where I'm coming from for these thoughts I have today. I mostly just went through and kind of looked at some of Jack's questions he had for us, and sort of going to address them from what my thoughts are. So. First, I want to say my assumptions about what we're talking about in the panel here. So I think we're mostly talking about research test beds, and I think that Jack kind of brought that up earlier. We're not really talking about clouds provided by academics for academics. It's a little bit different because like Jack said, we're not going to beat the public clouds in providing just raw computation. If you just want to run a bunch of compute and you don't need anything fancy and you just need millions of nodes, they're going to beat us. They might be expensive, so we have to consider that, but we're not going to beat them with their infinite capacity or what looks like infinite capacity. So what are we best for is kind of the question. And I think a lot of what our niche is being super transparent. So like when you're going to do research on one of these cloud test beds, if you don't know what you're actually running on underneath, you can't really say a whole lot about what you're doing. And I think Rob might I've seen him give talks before, and he has a really good talk about running things in Amazon and how it's not consistent at all. And I hope he talks about that because it's a really cool talk. And what you need, one of the reasons you want this hyper-transparency is so that you can do repeatable research, right? So the goal here ought to be for someone doing systems and networking research to be able to run their experiment, get some sort of blob of data that pops out the other side that they can then publish, and then everyone else can say, you did that experiment, here's exactly the infrastructure you used, and I can go try to repeat it, or I can pick at it and tell you what you did wrong, or something like that. That's the goal, right? And you can't do that on the public cloud, so that's our niche. Of course, there's specific cost-effective use cases, and we've talked about here, like pulling a lot of data out of Amazon is crazy expensive. So if that's what your use case is, then maybe you want an academic cloud. There's also cases with GPUs and bare metal and all these other things that people want to use are probably prohibitively expensive in the public cloud. So we can think about that too. So what are some of the future resources that we might need for the cloud? Well, there's all these standard ones that I think we all already know. So a lot of people need storage, so you want all these advanced storage technologies that are fast and different levels. Of course, from the networking side, we want smart NICs and FPGAs and P4 and all of these things. But I think we know all of this stuff. We know what we want. There'll be new stuff. We want to simplify incorporation of new hardware in the future. So like one of the things we want to do for both Chameleon and for Fabric is enable people that have weird hardware that they want to use that aren't in any of these clouds. If you give it to us, we can incorporate it. We want to do that. But I think maybe the most important part is to have better federation, both identity and tools, to ease the deployment and monitoring of experiments across all these systems. Because that's what we're doing now. Is that's why we're here. You guys have a whole bunch of these cloud systems here. We have a bunch of them. Rob has some. We're using them all together at the same time. So how do you make that work? How do you monitor an experiment that's across them all? How do you have an identity across them all? How do you make that repeatable? So how do you have hyper-transparency across all of these test beds doing one experiment? And I think that's a really hard problem that we don't really do well. And how do you publish that? Use case, this is what Honorbon presented yesterday. This is Dynamo. This is an interesting one that actually does use Exceed, Chameleon, Open Science Grid, and it uses Exogeny as the transport across it all. So, and this is specifically for scientific workflows, but there's other applications and other uses that'll use these things. It gets way more complicated. We're going to add Fabric, which is complicated. You can stitch to Amazon or maybe one of these wireless test beds. Okay, now the wireless test beds are going to have edge computers next to them. So how do you incorporate that into the mix and stitch them all together? So how do you make it easy to use all this and monitor it and record exactly what you did so that you can publish your experiment so someone can repeat it? Well, I don't think we really know how to do that yet. So barriers to adoption. So I'm going to contradict myself a little bit here, but so ease of use is what I've always thought. We need to train people how to use these things really well, and they'll use it, and everyone says, oh, it's too hard, I don't understand how to do it. But I'm starting to come around to the idea that maybe that's not actually the barrier, because you go to different conferences and workshops and things, and people publish papers where they didn't use a test bed, and they probably should have, and the thing they built to do their experiment is really, really complicated, and they did it on their own without anyone's help. Okay, so if they could do that, I think they can learn how to use Chameleon. So maybe it's not that we're not teaching them well, maybe it's just that we're not, they have cultural norms in their community that they just don't know about us, or maybe they just, they think that we're a cloud. There's this word cloud. So does that mean that they're not going to get to know the bare metal level of what they're doing? They don't trust that we're not giving them VMs and things like this? I don't know. We need to market it to them, advertise to them better, and give them, we need to, I guess what I'm saying here is we need to frame these test beds as scientific instruments. Maybe not as a cloud, not as a test bed. This is an instrument that you can tune and set up your experiment and then get repeatable results. And I think that we haven't sold that to many communities well enough for them to buy into it. And I don't know the answers to this. It's probably why there's so many words up here. It's because I'm still thinking about it. But if I knew what I was talking about, I'd probably have a nice picture. But And then we also need to have the transparency. I guess I've kind of already mentioned that, is that there's a perception of lack of control of the experiment when you run into the cloud. And with a lot of these test beds, you really have really fine-grained control of your experiment. And we just need to communicate that. Yeah. And I think this might be a marketing problem, not a technology problem. And it's possible that we are all mostly computer scientists and things like that. There are people that are into marketing and sales and stuff. They might have better ideas for us. And I've been talking to some people that have been thinking, that know about these things and trying to figure out how to relate it to what we're doing. So that's all I had. So.
Thank you, Paul. Up next is Rob Ritchie. Rob is a research associate professor in the School of Computing at the University of Utah, and he's also the director of the Flux Research Group. Dr. Ritchie works extensively, as you know, in infrastructure and has since the year 2000, including building test beds such as Emulab, Genie, and PhantomNet. As was mentioned before, Rob is the PI of the NSF-funded Cloud Lab research infrastructure. Thanks for coming, Rob.
All right, thanks. So the thing that I want to talk about today is kind of what it is that the community that does systems research on clouds needs that is maybe distinct from the community that uses clouds commercially and the community that wants to do sort of science on clouds as just users of those clouds. And not surprisingly, Paul already brought up a bunch of the things that I was going to, so I guess that gives me like time to ramble on about other things. Let's see if this works. Okay, so just as a kind of, so these are the three communities that I just mentioned, and each of them, obviously there are some needs that they all have in common, and there are also some things where their priorities are different, right? So, for example, people who use public and private clouds are often willing to pay for higher availability, right? If I built a research facility that tried to have the same uptime as a commercial cloud, it would be far more expensive, right? I would be building a much smaller facility with the same budget. There's the cost of having 5 nines of reliability is quite high. I like to tell people that we can give them all the 8s of reliability that they want, which isn't to say that, obviously researchers would like the thing to be available, right? But, they would, for example, rather that I spend my money on more servers than on generators to provide that extra 9 of reliability, right? People who run clouds for researchers are probably familiar with. People who are doing science using the cloud as their platform, generally want an interface and an experience that is a lot simpler than what you would give somebody who is, doing DevOps on top of the cloud, right? If you give a chemist or a biologist, the console for any one of the public clouds, right? Most of them are not going to even know where to start there, and so there are efforts like the Jetstream Cloud funded by NSF. There's now the New England Research Cloud, and I'm sure John will have some stuff to say about this soon too, right? That are aiming to serve that community. So the community that Cloud Lab and to some degree by extension OCT is trying to serve is essentially these people down here in the bottom who are, not necessarily happy with the cloud software stack that they would get if they went to somebody else's cloud, right? Who are, wanting to, build their own storage systems from the ground level, right? Who wanting to work on like the actual hypervisor and virtualization that's down at the bottom level. So I have actually only one more slide that covers the kind of what I think are four of the main needs that this, community of people who want to do research on modifying the cloud needs that are maybe lower priority for those other communities. So, again, the ability to modify the stack, right? So, we have people, for example, who, are, not satisfied with the way that, Kubernetes does job placement or something, right? And want to be able to modify the way that it does job placement, or who want to take, a distributed file system like Ceph and, change how it works. There's also, so that kind of, fits in with the build your own as well. We have a bunch of users who actually want to be able to, build their own storage stacks, build their own hypervisors from the ground up. So on transparency, this is a really big difference, I think, between what you get, especially from a commercial cloud, in the sense that, I have users who care a lot about what specific path their packets traverse, across our switch fabric, right? Who care a lot about like which specific ASIC is being used to switch their packets out in the middle. And so when you and this, that kind of stuff is, part of the infrastructure in a commercial cloud, right? And is usually intentionally hidden, right? And it's our we are in a position where we can, open all that, make all that stuff completely open. And then reproducibility. I think there was a question yesterday, somebody was asking about reproducibility and using some of the tooling that is used for the public cloud. I don't know if that person is still here, but as it turns out, right, there's performance reproducibility is pretty different than an SLA. Right, so we do a lot of work to make sure that, like, if you run a performance experiment on our environment, essentially you can't tell which machine it came from, right? Because they all, are representative of the same performance distribution, right? That's substantially different than trying to provide somebody an SLA. And in terms of providing tools, the tools that we provide are actually not very good for elasticity. They are very good for saying, here is a box that I'm going to run my experiment in. It's a description of the hardware, it's a description of the network, and all that kind of stuff. And so that I can hand that directly to somebody else and have them run the same thing. And this is related to things like operations kind of tools and orchestration kind of tools and that kind of stuff. But it actually is substantially different when you get into the weeds of like what it is that people actually need. So I think with that, my time is up, and I'll hand it over to John.
Thank you, Rob. John Cohn is up next. He is an IBM Fellow in the MIT IBM Watson AI Research Group in Cambridge. John earned his PhD in computer engineering from CMU. He is a Fellow of the IEEE, and in 2019, he was awarded the John Coma Education Award for his work in STEM promotion. John, thank you.
Right. So I am John, and I am actually an IBMer, but I'm pretending to be an MIT person. I'm a rabid MIT fan. Went there back in the 70s, and actually started Vermont's own MIT club, Vomit. I'm going to talk about Satori. I'm actually on the other side. I'm on the user side, and I'm going to talk, and I think from a standpoint of, where's the clicker? From the distinction. So I'm going to talk more about infrastructure for cloud computing for research, and I think that both Paul and Rob have everybody's sort of talked about that. I'm specifically talking about a research cluster that that IBM has helped MIT build. It was provisioned, I think, I remember it. It was a cold day, September 30th, and I got to turn the darn thing on. It was great. It's a 64 compute node AC922 Power AI system. It was announced by our executive vice president, number 2 guy in IBM, John Kelly, as kind of a slice of Summit. So we had started using Summit quite a bit for advanced computing. And it's designed to support a variety of research workloads. But what's interesting to me as an AI researcher is that is just expanding like crazy, whereas HPC was, a bunch of people kind of all sort of look like you. AI is like just exploding like crazy. And what we found at Chris Hill, who's my collaborator, who, by the way, I think he said he misbehaved at a panel yesterday or at a session. So I'm supposed to, so you were in the meeting. Okay. But basically, he says that we have a demand of 5x more accelerated compute, that is GPU and other accelerator compute at MIT than we could get handled. We are big users, they are big users of commercial clouds, including IBM Cloud, Google Cloud, and AWS. We spent well over $1 million in cloud there. But the point is, for these giant AI problems and for some of the HPC simulations, you really need a tightly connected, highly accelerated, high GPU. So Satori is a 2,560 Power 9 cores. It's 260, actually, NVIDIA V100s, very deep memory, over a terabyte of real memory per core, fast interconnect, 2.9 petabytes of storage. What was interesting is, by accident, we got to be the #4 most efficient green supercomputer in the world. So when we were going for our top 500, it turns out that our energy, our flops per watt put us #4, which is interesting, just as a plug for IBM. Of the top 5, 3 of them were IBM systems, just because of the configuration. It lives at Mass Green High Performance Data Center, and we'll come back to it. Just a quick note that Satori means sudden enlightenment, but the actual story, if you want to know it is my dog, Satori, and I actually have socks with her name. So I think that if you doubt that I'm committed to real compute, that's so basically, we've been working, and I saw Rob and Paul talk about this. We are trying to serve a research community, very diverse, and it's amazing to me. I think you both said something like this. These people are 5 times smarter than any of us, but they can't figure out a cloud interface. So we've worked very, very hard to make this an easy unified access. And because it's power, which is not obviously the dominant thing, they don't want to learn a lot about the differences. What's so interesting in AI in particular, because of the open platforms like PyTorch, TensorFlow, Keras, et cetera, it's really isolated any of those differences. And we've been remarkably lucky. Every workload just seems to work pretty well. We've worked very hard to make it easy to access. It's through a thing called Open On Demand. It's the same portal that we use for the x86 clusters that are around. MIT, like most universities, has lots of small fiefdoms, but we're getting more and more of them on this Open On Demand. It's also our interface to some of the clouds, for example, AWS. So we've made it super easy. Any MIT student or researcher can go on there, and he or she will be instantly on there, can get to a terminal, can get to a log, and can run right away. We all have a lot of peer support documentation, et cetera. And we've been working very hard, especially using what's called Watson Machine Learning Community Edition, which is an open source stack to make sure that when you start a machine, it has the AI stack. It's again, 90% AI. And together with some of these other open components, it's become very easy to use. There's Chris, behaving in that picture, by the way. Our early experience has been very good. We actually turned it on for everyone to use basically January 1st, kicked it up with a hackathon where we got a lot of response, specifically around speed up and power down. We're trying to build, if I get to it. We have over 220 users since January 1st. The average users is about 120 a day. I just noticed there are 270 jobs on it right now. Example workloads are everything. It's just, it's such a wide range. Everything from basic material science, but almost all of it is using ML as machine learning, deep learning. One project that I'm actually on is this Train Once multi-hardware. This is for optimizing machine learning models for things like phones. We've got the group is showing a 4x speed up over the hardware that they had before. We're also trying to figure out how we can enable have-nots. So we've got some local high school students who are working on it. And since everybody else is saying FPGAs, I quickly added, we also have an Acorn FPGA thing. So we're this much research and this much cloud research. So we've got a couple of extra nodes where we're putting crazy hardware people and kind of keeping them at arm's length and only elbow bumping them. One interesting thing, just that I think I'm probably pretty close to out of time, is if you watch how ML and machine learning, deep learning are growing, if it's on the same trajectory right now, we're going to, projections are it's going to use a substantial part of the world's energy by 2030. And we just can't let that happen. As it turns out, because the machine was number 4 on the Green 500 list, and because it's at mass green high performance, which I believe, John, is 97% green energy? 95? Oh, well, and forget it. Okay, but anyway, that we're about 70 times better in terms of carbon. So as part of this test case, you see these green computing things, we actually projected LINPACK using actual calculations that if you ran something for a year on our system in MGH-PCC versus a, quote, typical, and we actually have the numbers if you want to know, it's about less than 5 maple trees, since I'm from Vermont, worth of carbon on our system, and it's about 280. And so we're trying to give people feedback, so anyone who uses this machine gets feedback on the carbon costs. And it's very important to do that because we're not trying to green shame them, or anything like that. What we're trying to do is get better evolution of software so that, we just can't keep doing labeled supervised learning. We've got to develop it. And the only way that you'll do that is to start getting feedback like you do when you buy an airplane ticket. My last thing is a wish, and it sounds like everybody in this room is way ahead of me, is we're lucky to have this, this beautiful machine. Oran's got, we've got MOC. I've been talking to Jeff Brock at Yale. I'm a professor, I'm an adjunct professor at UVM. It just seems like we should be able to network a bunch of these together. I was just talking to our colleagues over there. I believe that by networking these things together, we can augment. We don't want to compete with public cloud. I am a public cloud, but what we want to do is we want to be able to make these highly accelerated, transparent for all the things that Paul and Rob and Bar were saying. We want to make those things available for researchers of all different types. So you can make better choices of cost and throughput. The main driver, as I think was brought out, is for this kind of accelerated costs, it's hundreds of thousands of dollars per month if you really want to build something that runs on 200 GPUs. So we've got all these participants, but I think we've got the collection of enabling technologies, OpenShift, storage, these high storages, fast fiber trunks in these public clouds, and I would love to talk about this with anybody else.
Thank you, John. So I just wanted to point out, before we turn to questions from the audience, that I had asked Elizabeth Bruce of Microsoft to join us, and unfortunately she fell ill just yesterday. So I just wanted to take the opportunity to introduce Elizabeth to you because I hope to bring her back at a future workshop. So she is the University Relations Director in the Technology and Corporate Responsibility Group at Microsoft. It's kind of an executive level area at Microsoft. She works across divisions from research to product teams, providing cross-company direction on strategic university engagements. She is an awfully good person to know, and that's why I'll bring her back, because she carries lots of Azure credits in her pocket. So that's one reason, but also that she's been working very hard on integrating university sort of IoT and sensing applications with some software they have, Azure backend software, to process all that sensing information at scale. So if you have projects of that ilk, particularly in the digital agriculture space, which I was hoping she'd talk about today, kind of a different application, she will be a good person to talk to, and we'll welcome her at the next workshop. So I'm going to invite you to come up and ask questions of the panel. I'm going to kick us off with just one question on a topic we haven't gotten to, and I'm opening it to all of the panel. So I said earlier that cloud research infrastructure is particularly well suited to providing a sort of a parity vehicle for folks at underserved institutions. So I'd be interested in what the panel thinks about how effectively we have served the folks at those academic institutions that maybe can't afford the sorts of local resources that many of the institutions represented here can, how effectively we've reached out to them, and how effectively we're training the workforce that they're attempting to serve. So let's kick it off. Any of you want to start with that, and then I'll ask the audience to come up to the mics and help us with some future questions.
I can start. So, we have these on?
Yeah.
Okay. So, I think one thing that has come up in many of our activities with some of these institutions that serve underserved communities is they tend to be teaching institutions and not so much research institutions, right? And it tends to be the case that the faculty there tend to have much higher teaching loads. And so I think one reason why we have not had more people from some of those universities using our facilities is that essentially what is most useful to them is to come to them with a lesson plan, et cetera, that uses the facility and that can integrate into a course that they're already teaching, right, and to save them work. And instead it looks like more work to figure out how to use one of these platforms and to adapt assignments to it and stuff. So I think that's one thing that we focusing more on the educational aspect and focusing more on pre-canned courseware is something we can do to serve some of those underserved populations better.
You want to go? Go ahead.
So I feel like we could definitely do a lot better. I talk to a lot of smaller schools all the time. If you looked at the vision statement for the ERN, pedagogy was part of the vision. And that was partly because with the conversations we've been having with a lot of the smaller schools is that they may not necessarily need all the research computing and capabilities, but they do want to integrate really interesting data sets into their curriculum. They're all thinking about data science now, and because that's what we're all talking about, artificial intelligence and data science. And they've got to figure out how to serve their students so that they're prepared to go out into, get jobs in industry at other universities. And so they are desperate to get access to these systems, but it is a little daunting, as Rob said. They've got these workloads, and a lot of times, it's easier for larger universities because we're connected with internet too. We use in common. We've got all these different ways of accessing these resources, whereas the smaller campuses tend not to participate in those. So that's where I think the regional network providers can really help provide gateways to these resources. But it is going to take land-grant institutions to realize that we need to go out there and have conversations and educate and do a lot of the hand-holding to help people transition into these environments. So there is a lot to be done, and we can help. But the success stories are usually because we go to a conference, we bump into somebody, they said, "Oh, I'm struggling with this." And then, maybe meet up with John Goodhue, or actually, it's a regional network provider. They have these regional conferences that a lot of the small schools go to, and I'm hitting all of them now. But they talk to the CEO for the regional network provider saying, "I'm really struggling with this." So Dave Marble in Rhode Island then connected that person to John Goodhue at MGHPCC, and then they got access to a resource there. And so, we've got to streamline those processes so we can do a lot better.
So I am putting my University of Vermont hat on, and while it's not, I wouldn't call it underserved, it is a land grant. I think what's happening is that with the fast rise of ML and deep learning, you don't have to, I think the main thing that groups like this will offer is access to accelerated computing, specifically GPUs and whatever comes beyond it. And while all of the public cloud providers, including us, provide GPU resources, it's exorbitant. So if you, what I'm finding is everyone, including high school students, are coming just looking for GPU resources that are affordable. And while it used to be an HPC person would spend a lot of time thinking about how their problem was going to be laid out on a cluster, et cetera, or on a cloud, now all you have to do is take like Andrew Ng's ML class, and you can put 64 GPUs to use. That would be hundreds of thousands of dollars, and that's certainly out of the grasp of most of the universities in Vermont. So this kind of thing, until something better, until we get better at doing semi-supervised or unsupervised learning, these are a lifeboat, and I think that is something that these underserved universities will never have access to unless we do something. Now, I think that story will be very different in about 5 years when we have better AI techniques, but I think this is, I have to say, I feel like I don't sense that wave here, but I do sense it if you walk around on a research. I'm curious if you are seeing that same, all of a sudden, everybody's an HPC person, whether they mean to be or not.
I could add that there are GPUs in Chameleon, and they're by far the most high demand thing that there is. I think Cloud, that's similar. And like we have an advanced reservation system, and where you have to have an advanced reservation for everything, even if you want it in a minute. But the GPUs specifically, like you probably can't get one for the next couple of weeks because and that's
we're
just,
already full.
Yeah.
After 6 weeks.
And that's just all the time. In fact, we have. One of the problems we have is that we have policies on how they can reserve different things, and they're very good at trying to game the system, and we just are constantly fighting this battle with people stacking reservations on top of each other, and it's like, how do we prevent that? I don't know,
They're actually creating
whole nother
AI
problem.
to do that. They're creating AI to game the system. We're doomed.
And so I was going to say that I'm now having, people outside of the academic side of the university coming to me for help. So I had the head of procurement set up a meeting with me because he wants to do all the data analytics and AI and automation within his shop and doesn't know how to do it, and so they're coming to us for help. And when we do AI training, the chief financial officer from Rutgers is now sending people to learn how to use our system. So it's not just research that needs this stuff; it's everywhere. And it turns out that it's just a few of us. It's a small community that knows how to help everybody. So we're in high demand.
I will add, unless someone else said something about GPUs, but what Bar said earlier about in common, this is a kind of a big deal, especially for the MSI type institutions that we were talking about, the minority serving institutions. So most of these systems use some federated identity mechanism like in common. Chameleon doesn't yet. We're going to move to it. But in my experience and all of like Genie and all the different systems I've worked with that use these federated identity systems, when you go give a tutorial with a group of small schools, the most difficult thing to do is to deal with the 20% of them that can't even log in because they're not a member of InCommon or whatever it is you're using, and that's a big hurdle right there. Like, I can't imagine what they would do if we weren't sitting in the room trying to get them logged in for the tutorial. They would have given up a long time ago. So, I mean, maybe that's a thing we should deal with.
Yeah. So we were talking earlier about underserved institutions who aren't necessarily connected to this infrastructure. And that made me think again of the conversations we had yesterday about the discipline, the emerging discipline of large-scale operations, and the the prospects of teaching that in colleges and universities, not as a learn, go, so you can be a Google SRE class, but as an actual discipline that might have more in common with process theory or urban planning than it necessarily does with computer science, for example. I guess my question is, what can we in industry do to help make that happen? Because we're desperate. And if we had more curriculum along those lines, would it help the smaller institutions to get more engaged with these kind of things?
So, I don't know. I don't know how many institutions have something like this. I imagine that many do. But so, like for example, our department has an industrial advisory board actually, where we have people show up and tell us what kinds of what areas they wish that we were educating students in. And so, if you are near an institution that has something like that, participating in it would be a really good way to help make the case that that is something that that we should prioritize. So, for example, in our department, we have bulked up our security faculty in part because people came to the IAB board and kept telling us we need your students you're graduating to know more about security, right? That's something that people in the industry can absolutely help convince our administrations in the universities that it's important.
So, so the way my group is structured, I've got, I report both to the CIO and the VPR. So we really are the bridge between those two worlds. And so I've got research scientists on my team who work on research. They understand research, and they are the front line to the rest of the university, to our resources. Then I've got system admins who build everything, and then I've got a business office that manages it all. So what we've found that has been extremely successful with industry, and Google's done this, is come in and train our research scientists on how to use those services, because we are running training across the entire university system in the state of New Jersey. So we run training in Camden, Newark, in New Brunswick, Piscataway. We run it for the medical and non-medical communities. And what's starting to happen is these our training modules are now being looked at as possibly becoming embedded within the curriculum, right? So the practical with the theoretical, we offer all the practical hands-on training and set up the module. So if my team really understands what the industries are trying to do, they can incorporate that directly into the hands-on practical side of it. So, and that's been extremely successful. Like I said, Google's already done that with my team, and we're just incorporating that everywhere. So,
Hey, Bar, can I ask you a question?
yeah.
So, and I think that's great that Google's doing that. How concerned are you, or would people be, about being locked into any particular cloud or particular? So we have a bunch of proprietary tools and we have open source tools. We'd like to use both. Do you
We're
you or the
agnostic.
people you're talking?
We're agnostic. So so Google partnered with us on it, but we stand up AWS services, Azure services.
Slightly different question. So
Okay.
I get that, but I mean, if you had to build in something that was proprietary to one of the clouds, say ours or Google's,
Right.
is that a problem? Or you'll use it if it's there, or you will
We'll use it if
explicitly
it's
not
there.
use
So
it?
it's completely dictated by the research community, right? So if they come to us and they say they absolutely have to have this, first thing they'll do is sit down with our research scientists and find out if that is actually true. And if it is true, then we will do everything possible to help them get access to those resources.
Okay.
If I may, I had a question, maybe also a little bit of a comment. So, Bar, you said, we are the few on the front line, right? And it's only the few of us. And when I think of the smaller schools, minority serving institutions, they have a huge teaching load usually. And so are there any activities in actually kind of, train the trainer, teach the teacher, something like that? Because I think that would be the multiplier that's requested. I know if you're doing something in that area.
So our team is just getting into that. So we inherited a statewide compute system.
Congratulations.
Thank you. So it is available to every school in the state. It is available to industry partners within the state. It's also available to state offices. And so we are in the process of hiring people specifically to go out and do that outreach. And so there are a lot of state initiatives where these communities come together. There's recently been set up this New Jersey Big Data Alliance, and they have regular meetings. So we're going to start running training across all of those just to try and help with the hand-holding to get access to those resources.
And so the NSF Future Cloud Projects, Chameleon and Cloud Lab, a couple years ago ran a workshop that had a bunch of small colleges in the South, had a bunch of people from the University of Puerto Rico system that came and learned how to use the platforms. It didn't go a whole lot beyond that, and I think that comes to the having prepared curriculum, right? Many people who have very high teaching loads are not spending a whole lot of time doing new curriculum development for themselves, or if they are, it's what they're going to focus on is the curriculum and not necessarily the infrastructure used for labs, right? And so I think that was a valuable experience, but we also need to have some prepared curriculum.
I just double down on what Rob said, that UNC actually there's an institute called the Silver Institute, and they had for several years in a row a workshop where they brought teachers in from smaller schools, and I went there and did tutorials every year about all these things that we've worked on, and I can't remember even one person that was from one of those that I still know uses any of them. And usually, most of the times at a tutorial, if someone got really excited, I probably still know that they're working on something. So I think what Rob's saying is absolutely true.
So maybe as a comment, if someone from a small school is in the audience today, this is your opportunity to tell us also what you need. We would like to hear that. And you might be surprised, there are actually small schools even in Massachusetts. Right?
I was going to say that we have IBM, and I think most of the cloud providers, I know that Google does, have something called Skills Academy, which is exactly around trying to create curriculum to train the trainers, and I could put you in it. But I think the main thing is it needs to be informed by the need. Yep. So if you, small schools especially, we need to hear from.
Thanks. So I should also mention that the ERN submitted a planning grant to NSF to hopefully get funding for a series of workshops. One of them is specifically focused on small schools, underrepresented schools. So, fingers crossed that it's funded so that we can pay for everybody's travels to the workshop, and also that the coronavirus calms down between now and then.
Please, if you have a question, ask while the panel is available. I'll fill in by asking a question about technology transfer. So how does the panel sense that we're doing in terms of pushing technology discovered in part on cloud research infrastructures into actual commercial cloud production systems? And should we be doing anything different to further accelerate those technology transfers?
So I think we don't do a good enough job at that. And I think that one thing that could help, that we've been thinking about for Fabric especially, is that most of these test beds explicitly say, don't run production traffic on this ever, don't run production anything ever. And I think that with Fabric, although we're also not supposed to use production traffic, we're kind of going to bend that rule as best we can and say we want to support semi-production traffic. And that's sort of part of our philosophy of connecting to all the real things and being the network that's connecting the real things, not little sandboxes of test nodes. What we want to do is incubate people's experiments that have become a little bit proven and let them opt into production traffic and let them run their experiment for real And then as soon as they're very successful, we can go talk to Internet 2 or ESNet or whomever and say, hey, you guys should really take this really successful project away from us. That's also part of the reason why Fabric has such high bandwidth and things like that, is we want to be able to do things at the scale that of production, but without actually saying we're doing production, because we're not supposed to, right? So like maybe that idea is like maybe that rule shouldn't be there, and officially, I don't know.
So there are a couple of specific models that we've used in Cloud Lab along those lines. So, we do have a significant number of users that are, academics and contributors to various open source projects. So, for example, a lot of the team that does the KVM QEMU hypervisor for ARM, is or was, I guess he's graduated at Columbia University, and used Cloud Lab to do that development. And so the stuff that he developed on our platform is in the mainline Linux kernel. And we have other people who are users are contributors to other systems, right? The other thing that we have tried is that we have a particular project. There's a data center / telco coordination infrastructure called CORD, Central Office Reconstructed as a Data Center. That was originally an academic project. It was started originally by Larry Peterson, who was, I don't remember why he was Princeton or after he moved back to ASU. But anyway, so it started as an academic project, but now one of the things that they're doing is, working on getting other commercial entities to adopt it. And so we have a project on Cloud Lab that they manage the membership of, where people can come basically try it out, right? So they're not running production stuff on there, but if it's like, hey, I'd like to try Cord and see what the heck it is and get my hands on it, then there's a way for them to do that in our platform. And I think that that's another way that some of these academic platforms, without becoming production platforms, can still facilitate tech transfer.
Hi, my name is Jinjun, and from IBM. I have two questions. Through the whole 2 days, right, and I learned a lot of this cloud platform for research. But two things is not clear to me. The first thing is, in order to understand that for the cloud research, you need to have the cloud scale kind of workload, right, and the service request. And how do you guys generate such kind of cloud scale request and the workload, so you can really understand the workload and the scalability on your platform? The second question is about the storage. If I'm coming to your platform, you say, okay, this is not a production quality, it's just for research. Whenever I go to your platform, I need to do some experiment. I have a lot of data. I mean, of course, you said you provide some public data access, but a lot of times research, they have their own data set as well. If you want to talk about the cloud scale kind of research, the data set can be terabytes or petabytes. But then how do I transfer such a data set into your platform? And then, okay, maybe I ship your disk or upload it through the network. Maybe after running for a couple of weeks, you say, hey, this is not a production quality platform. It's gone, poof. What I'm gonna do? I'm going to use your platform, upload the data again. So what is your solution right now for these two questions?
So I will answer from the perspective of serving the systems research community, right? So, so the answers will be different for some of these other communities. But to answer your first question about workload generation, that is up to our users, right? So like, for example, we have a bunch of people who do work on various key value stores over RMA or over RDMA, right? And so, in that case, they're using things like the YCSB benchmark from Yahoo. And so kind of it is in that case the researcher's job to sort of know what the workload that they need is, and to subject their machines to that. We have people who do security work, right? Where their workload is a DDoS attack, right? And they generate that stuff on it. We have a public network and a private network, and so long as they do it on the private network, we're fine with that. And so the workload, we can't really provide a workload because the people are doing such different things. And then the other thing about kind of the size of data sets. So again, this answer is specific to the systems research community. A lot of systems research does not actually use big data sets. So like even, for example, large file system kind of stuff, right? Like they don't actually care what is in the files, right? They can generate them on the fly, right? If they're doing a key value store, they can generate that stuff on the fly. And so a lot of that community, though they're dealing with systems that handle big data, they don't actually need that big data themselves. Now, the one way that that is changing in the systems research community is people who are doing things like the systems to support things like ML, where they need a data set so that they get a realistic execution. The good news from our perspective there is that in general, they are not trying to train novel models. They are trying to see how well, their system can support training of models. And so a lot of them use perfectly standard data sets, right? And don't necessarily need to, we're working on providing sort of more of those data sets in-house so that they don't have to even transfer them in. And so that saves them from having to transfer a lot of data in.
I would add, from Chameleon's perspective, we actually have, it's like a 1.5 petabytes of object store that you can store stuff in permanently. Hardly anyone uses it, but if they wanted to, they could. So if you wanted to do exactly what you just said, you could. We also have, I think, Cloud Lab also has and Chameleon has specific nodes that have lots of disks in them, so you can get like something that has like 32 terabytes in one node and rate it however you wish, because you just get raw access to the whole thing. And we have these storage hierarchy nodes that have NVMe and SSDs and all sorts of stuff. So if you really wanted to do something that involved a lot of data and storage and moving it around and a lot of it being permanent, all that's possible.
But I think,
but also the systems people tend not to. That's why our object store is not even used.
Yeah, I was gonna say, I mean, one of the things that you sort of notice in that answer as well, right, is that the kind of research, at least that Cloud Lab and Chameleon support, right, tends to be more about the movement of the data, the design of the system, rather than the use of that data.
I would say from the user side, with the Satori cluster in Mass Green High Performance Center, we've got about 2.3 petabytes of storage, and what we're trying to do is actively find, because a lot of the stuff, especially the video and vision stuff, uses these huge data sets, and we're trying to recognize when somebody's trying to move something over, and so we've got shared storage for a lot of it. Now that stuff tends to be not very sensitive, so it's easy to do, but we're trying to figure out, well, what would we do if that had personal information, et cetera. And I know that there's efforts, I don't know if John Goodhue's still here, but there's efforts to think about, because so many of us are clustered now in Mass Green, could we create a shared storage facility there that was, maybe HIPAA compliant or something like that. But
the NESI project, which is doing exactly what you said at MGHPCC. There's a poster about it, and we can talk.
I'm supposed to come and watch it.
Okay, at the risk of standing further between you and lunch, I think we'll call an end to the panel. I hope that the audience got some learning from folks who've been involved in research infrastructure on the panel for some period of time, and that their understanding informs some of the decisions that will be made in Open Cloud going forward. So please join me in thanking the panelists, and we'll see you at lunch.
So if I may follow up, also please join me in thanking Jack. Jack, I know, and a bunch of you know you from like the early days of Genie. That's how we all got together in this stuff. So this is way more than 10 years ago. You spent several years at NSF, overseeing the cloud project, the NSF cloud projects, and so it's great always to have you in the community and giving your deep insights with all the experience you have done over the years at HPC research, HP research, sorry, and NSF, and now back at Princeton. So thank you very much for organizing this very interesting panel, and thank you all for taking part in it. Did you want to say something about
Yeah, I think